This lesson is on section 8.5, angles of elevation and depression. For our last few sections, we've been talking about how to solve for missing values in right triangles. We've looked at the Pythagorean theorem, where if we know two sides, we can find the third. We've looked at special right triangles, so we know if we have a 30-60-90 triangle or a 45-45-90 triangle, and we know one side, we can find the other two, using our ratios. And finally, we worked with trig functions in our last two sections. So if we know one angle or two sides or some combination of those things, that we can use sine, cosine, or tangent to find our missing values. Today what we're going to do is we're going to add perspective into those problems. So they become story problems, but really they're still just right triangle problems that you can use whatever you have to solve. The only difference is now we're going to be talking about how people are looking at a problem and where people are standing and where the objects are in relation to each other in order to find that right triangle problem. We're going to be looking at something called the angle of depression and the angle of elevation today. The angle of elevation would be if somebody or an object of some kind is standing and looking up at a figure, then that would be an angle of elevation. This would be the line of sight, and they would be looking up at something in the distance. That would be an angle of elevation. Angle of depression would be if something is above, their line of sight would be right here, and then they would be looking down at something. That would be an angle of depression. Okay? If you'll notice, an angle of depression and an angle of elevation, these lines of sight would be parallel because they would be horizontal. And then when you connect them with a transversal, they make a Z shape. What have we learned about a Z shape? That your angles would be congruent because they're alternate interior angles. So an angle of depression and an angle of elevation will actually be congruent to each other. If you know one, you'll know the other. They have to be congruent to each other. The trick is, in the picture, knowing what you're looking at, where the line of sight is, and whether you're looking up or down from that line of sight. That's going to be your trick. Okay, so we are going to start off by just being able to describe what kind of angle we are looking at. Okay, for example, if there's an airplane looking down at, let's say, the Parthenon ruins, how would you describe angle 1 and how would you describe angle 2? Angle 1 is from the plane's perspective. They are looking straight out of the plane and they would be looking down at the Parthenon, and so therefore it would be an angle of depression from the plane to the Parthenon. It's important that you write from what to what. Okay, so we would say angle of depression from plane to Parthenon. In a similar fashion, if we were standing down at the ruins looking up at the plane, our line of sight would be horizontal going this way, and we would be looking up at the plane. So in this case, it would be an angle of elevation, but it would be from the Parthenon to the plane. Okay, so that's how you describe angles. All right, now we're going to get into problems where we actually use those. Okay, this example says a surveyor is standing 2 feet from a building and he wants to measure the height of the building, and he's got a 5-foot tall theodolite, which is a figure that allows you to measure angles. Okay, the angle of elevation that the surveyor is seeing to the top of the building is 35 degrees, and they want to know how tall is the building. The first and major part of this question is to put your pieces in the right spot. Okay? if I'm measuring the height of the building, chances are the building is going to be right here, and this is what I want to know. I want to know how tall the building is. Second of all, I've got my measuring device is 5 feet tall, so that means I'm taking a perspective shot at the building. So I'm over here, or the surveyor's over here. However, his line of sight is going to be 5 feet off the ground. It's going to be 5 feet above where the building actually starts. The third piece of information that we have is that it's an angle of elevation. So from the surveyor, we are looking up at a measure of 35 degrees. So that would be this angle right here. Notice it makes a nice right triangle. Okay. When we go to find out how tall the building is, we're going to have to set up a mathematical problem. Okay. I know that the surveyor's 200 feet from the building, so I'm going to put the 200 right here because that shows the distance between the building and my person surveying. This kind of problem, I know one side and I know one angle. I'm trying to find another side, so that tells me I'm going to have to use my trig functions because it's not a 30, 60, 90 triangle or a 45, 45, 90. So I'm going to set up a trig function. So I'm going to decide my side x is the opposite side compared to my 35 degree angle, and my 200 side is the side that's adjacent. The hypotenuse is over here. So if I'm going to use opposite and adjacent, that tells me, and I'm going to put SOHCAHTOA up here so that I have a reference to look at. So opposite and adjacent tells me I'm going to use tangent. So I'm going to set up the problem. The tangent of 35, because the angle measure goes next to the tangent function, and then it's opposite over adjacent. So I'm going to put x over 200. I'm going to solve that problem now. Since the x is on the top, to get the x alone, I'm just going to multiply by 200. So I'm going to take 200 times the tangent, 200 times the tangent of 35. And when I take 200 times the tangent of 35, I get 140. Okay? So that tells me that from here to here is 140. It's actually 140.04, but 140 is close enough. Now, that does not necessarily tell me how tall my building is, because you have to remember that the surveyor started 5 feet off the ground. So if from here to here is 140 and from here to here is 5, the actual height of the building would be 145 feet total. The next example is one where we're comparing two buildings. It says the two buildings are 30 feet apart. Okay, so I'm going to put the 30 right here because that shows the distance between my buildings. It says the angle of elevation from the top of one building to the top of the other is 19 degrees. So that means if I'm standing on the shorter one and I'm looking up, because it's an angle of elevation, that angle is 19 degrees. And the question is, what is their difference in height? So in other words, what is this value right here? Again, I know my angle and I know one side, so I'm going to use a trig function. The x is the opposite side from my 19. The 30 is the adjacent side from my 19, so tangent is the one I'm going to use. So tangent 19 equals x over 30, opposite over adjacent. So I'm going to take 30 times the tangent of 19, and I'm going to get 10.3, and this is feet in feet. So the difference in height between the two buildings is 10.3 feet. I have a lot of kids who have trouble determining angle of elevation versus angle of depression. If I were to erase this problem and instead change it to say that the angle of depression is 19 degrees, I have a lot of kids that would put the 19 right here because that looks like an angle of depression. That would not be the case, however. Remember that angle of depression goes from a line of sight down. So that would be if I'm standing at the top of this building and looking down. So it would be this measurement that is 19, which, remember, the Z-shapes, angles of depression and angles of elevation are congruent because they make a Z-shape. So that would still put the 19 degrees right here. It wouldn't change the problem at all if it said the angle of elevation was 19 or if it said the angle of depression is 19, because angles of elevation and depression are congruent. So do not fall into that trap. That is the end of the lesson on angles of elevation and depression. The homework is as follows.